Welcome to week 8, question 2. And remember, we're looking at local and absolute extrema. So here's a question about the daily cost of producing X high-performance wheels for racing, and it's given by the following function. And it says we have a restriction that no more than 100 wheels can be produced each day. And we see that reflected here, 0 to 100. The first part of the question says, what production level will give the lowest average cost per wheel? You can see that average is bolded there because rather than just finding the lowest cost or the minimum cost, we're finding the lowest average cost. So we're given this cost function, and we know that to find the average cost function, we're going to have to divide that function by x. So let's see how that works. So we have the average cost is going to equal 0.11x cubed minus 5.5x squared plus 176x, and the whole function is divided by x. Now you'll remember that this division by x can be separated over each term, kind of like this. And we see that each of those terms above have an x term in it, so we're able to divide that x term, x out of each term. So let's simplify that a little bit. So we have 0.11x squared, now that's x cubed divided by x, minus 5.5x, because we have x squared divided by x, plus 176. So this is our new simplified average cost function. And again, we're asked to find the minimum average cost. So we know that when we're looking at maximum or minimum, we're looking at extrema. Extrema means that the derivative of that function is 0 at those extrema or critical points. So the next thing we're going to have to do is take the derivative of this function. So we've got 3 terms in a sum and difference function, so let's take that derivative. And now we have 0.22x minus 5.5. 176 is a constant, the derivative is 0. And so now we have a first degree function. And again, we need to solve it by setting this equal to 0. 0 equals 0.22x minus 5.5. 5.5 equals 0.22x. So x is going to equal 25. Okay. And we need to check, does 25 lie within the interval of 0 to 100? Yes, it does, so that's good. And now, how do we know if 25 is a max or min? Okay, then we need to take the second derivative and determine whether it is positive or negative. So the second derivative is simply 0.22, so that is greater than 0. So we have a minimum. So that's what we're looking for, the lowest average cost. That's terrific. So what's the next thing we have to do? We have to find out what that minimum cost is, which means we're going to be substituting x equals 25 into the average cost function, not into the original cost function and not into the derivative function. It's going to be the average cost function. So I'll take you to the next page and we'll work on that. So now that we know that x equals 25 is the lowest average cost per wheel, we want to determine what that average cost is going to be at that level. So we're going to substitute x equals 25 into the average cost function. Remembering our order of operations, we're going to do this exponent first. So doing that, multiplying by 0.11 and so on, we're going to find that the average minimum cost at a production level of 25 is going to be 107.25. So that means that the average cost is at a minimum when 25 wheels are produced, and that minimum cost is $107.25.